Okay, let's dive into what is seriously one of the most powerful partnerships in all of technology, the fusion of quantum computing and artificial intelligence. And look, this isn't some far-off science fiction dream anymore. It is quickly becoming an engineering reality. And honestly, it's on track to change just about everything. In fact, this is happening right now. The United Nations has officially declared 2025 the International Year of Quantum Science. That's a huge signal. It marks this clear shift from something you'd see in a movie to something being built on the factory floor. It's the moment quantum computation really starts tackling real-world problems.
So you have to ask, right, what's the big rush? Why this massive shift from classical to quantum computing, and why is it all coming to a head right at this moment?
Well, the simple answer is that traditional AI, for all of its incredible world-changing progress, is rapidly approaching its fundamental limits. The very engine that powers our modern world is basically running out of road.
Okay, so let's get specific about this wall. We're going to break down exactly why classical AI is hitting its limit and why that creates the perfect opportunity for a quantum solution to step in. And here it is. It's called the computational wall. It's this crisis point where the absolutely insane amount of energy needed to train bigger and bigger models and the explosion of data, it all just becomes unsustainable for classical computers. Progress doesn't just slow down, it literally grinds to a halt.
So to break through that wall, you need a totally new set of tools. Let's look at the three fundamental quantum principles that aren't just abstract physics. Think of them as the practical superpowers that quantum AI brings to the table. First up is superposition. The easiest way to think about it is this. A classical bit is like a light switch. It's either on or off, 1 or 0. But a qubit, it's more like a dimmer switch. It can be on, off, and a whole range of possibilities in between, all at the same time. This means a system with just a few qubits can explore millions of possibilities simultaneously, giving us a level of parallelism that classical machines just can't even touch. Next, we've got entanglement. This is the one Einstein famously called spooky action at a distance. When you entangle two qubits, they become linked in this profound way. The state of one instantly influences the other, even if they're miles apart. Now, for AI, this is a game changer. It lets our models find these incredibly deep, hidden connections in data that would otherwise be completely invisible. And finally, there's interference. This is the quantum system's secret weapon for zeroing in on the right answer. It cleverly uses wave-like properties to amplify the chances of the correct answer getting stronger, while all the wrong answers basically cancel each other out. It's like the ultimate noise-canceling headphone for computation, making the search for the best solution ridiculously efficient. So how do we actually put these superpowers to work? Well, the key thing to understand is that we're not trying to replace our classical computers. The future is all about building a hybrid brain, a powerful new kind of architecture where quantum and classical processors team up, with each one playing to its unique strengths. And this slide really shows that hybrid approach in action. Think of it like a conversation. The classical computer prepares the data and hands it off to the quantum processor. The quantum chip does the really heavy lifting, the super complex calculations. Then it sends back a result. The classical computer looks at that result and acts like a coach, telling the quantum chip how to adjust its parameters for the next try. It's this constant, powerful feedback loop that gets us to the right answer way faster.
And even within this hybrid world, it's not a one-size-fits-all solution. This chart compares two different quantum models. You've got quantum neural networks on the left, which are great for really messy, complex data. But for simpler problems, the quantum SVM on the right is often more stable and accurate. The main takeaway here is that we're building a whole new toolkit, not just a single hammer.
And here's the proof in the pudding. In benchmark tests, a hybrid quantum machine learning approach went head-to-head with a purely classical neural network. The result? The hybrid system hit over 95% accuracy. That's a huge jump over the classical model's 89.5%. That isn't just a small improvement, that is a massive leap forward. And I want to be really clear, this is not just happening in simulations anymore. The reason we're talking about this right now is because the actual hardware is finally catching up to the theory. Let's look at some hard evidence that this shift is happening today, driven by some major breakthroughs. Just take a look at IBM's public roadmap. This isn't wishful thinking, it's a clear, step-by-step plan to build a large-scale, fault-tolerant quantum computer within the decade. And they're not just aiming for more qubits, they're building the architecture for reliable, logical qubits that can run billions of operations without errors. That's the real goal. And this is what that progress looks like in terms of pure power.
A huge milestone from Google showed their algorithm achieving a mind-boggling 13,000 times speedup compared to one of the world's top supercomputers. That's the kind of performance leap we're talking about. It's just a different league.
But the most important word in that whole announcement is verifiable. This wasn't just some random calculation. The results could be checked and confirmed by a classical computer. And that's what builds the industrial trust you need for people to start using this technology for real-world applications. It's truly a historic milestone.
So what does all this power actually mean for us? Let's connect this abstract tech to some tangible, world-changing results that are already starting to happen.
First off, we're not just talking about solving little toy problems. Researchers have already shown a proven quantum speedup in training an AI model with over 100 million parameters. To put that in perspective, that's on the scale of foundational models like BERT. This is for real.
And this power is already being used to solve problems we just couldn't touch before. In pharmaceuticals, it's slashing drug discovery times from years down to months. In materials science, it's simulating molecules with bizarre, exotic properties that are literally impossible for even the biggest supercomputers on Earth to model.
So, if that's what's happening right now, let's look down the road a bit. What are the massive implications for industry, for society, and for all of us as we head towards 2035?
Okay, let's talk about one of AI's biggest dirty secrets: energy.
The demand is absolutely staggering. By 2027, just training AI models is on track to consume over 1% of all electricity on the entire planet. This is where quantum computing offers a critical path forward. Because it's so much more efficient for certain tasks, it gives us a way to slash that energy footprint, not by a little, but by orders of magnitude.
All of this leads to a brand new playbook for any industry that relies on data. The strategy is clear. First, embrace these hybrid systems. Second, use quantum's unique power to get more value from smaller, high-quality datasets. And third, and this is critical, start upgrading security to post-quantum cryptography right now, before quantum computers get powerful enough to break all of our current encryption.
And we'll end on this one last thought. There's a fundamental rule in quantum mechanics called the no-cloning theorem. It basically says it's impossible to create a perfect copy of an unknown quantum state. So if a true quantum AI is built on this principle, it literally can't be copied. This raises some absolutely fascinating questions about the future of intelligence itself, about intellectual property, and about security in this coming quantum era. Definitely something to think about.